When looking at metabolic reactions, it's really important that we understand how to read the arrows. And so if we look at this reaction here, I want to start off looking at reaction 1, which is going to be the conversion of molecule A into molecule B. Now, if we're looking at reaction 1, molecule A would be our reactant, and molecule B would be the product of that reaction. If we were going to write an enzyme in this particular reaction, that enzyme name is going to be written right above the arrow in the middle. And that's because the enzyme itself is not going to be consumed during the reaction, so it's present at the beginning, it's also present at the end. Now, if we want to look at how to read the arrows in the reaction, most students don't have any trouble with the arrows that are being shown here, but I want to look at reaction 2 where I haven't written anything next to the arrow so that we can look at it a little bit closer and look at arrows that take on slightly different shapes. Now, a lot of times you will see these curved arrows come in and then they come back out. And one common place where we might see that is we might see where ADP is getting converted into ATP. When we look at a reaction like that, since the arrow is pointing towards the ATP is going to be the product, or in other words, it's being produced, and ADP would be a reactant because it is actually going into the reaction or is getting converted into the ATP. So we do want to understand that when we have something going down and into the reaction, it is a reactant. Coming up and out, that is going to be a product. So those are a few examples of reading arrows. If we look at this reaction here, we can see that many times there's a lot going on in a single reaction step. In this particular reaction, we have multiple reactants and we have multiple products. If we list the reactants in here, just to make sure that we are all on the right track for reading the arrows, the reactants, the first one is going to be A, so molecule A is actually going in. ADP is also going to be a reactant because it is going in if you look at the direction of the arrow, and NAD+ is also a reactant. If we look at the products of this one, we also have multiple products. Products would be anything that the arrow is pointing towards. Our products would be molecule B, ATP, and then also NADH. Two other things to point out. If we see ATP being synthesized like we do up here, that would be an endergonic reaction. ATP synthesis is always endergonic and it would require energy. That means that there must be some energy available in this case to make that actually happen. If we see NAD+ getting reduced into NADH, that will be a redox reaction, and that means that electrons are being transferred. Specifically, NAD+ gained an electron from the reactant, which was molecule A. So NAD+ gained an electron from molecule A. That means that NAD+ was reduced and A was oxidized.